Hello, physics enthusiasts. Ready to dive into one of the most fascinating laws of nature? Let's talk about the second law of thermodynamics, which might sound a bit complicated, but trust me, it's all around you, every time you make a cup of coffee or when your phone battery heats up while charging. This law tells us something very fundamental: energy doesn't just flow everywhere, it's always moving towards greater disorder. Imagine your room. The more you move things around without organizing them, the messier it gets. That's essentially what this law says about energy. It always tends to spread out, and the total amount of disorder, or entropy, increases. Now, if you've ever felt like your desk just keeps getting messier no matter how much you clean it, you're already experiencing the second law in action. So, let's break this down and see how it all fits together. So, what's this entropy thing everyone keeps talking about? Well, think of entropy like the messiness or disorder of a system. In physics, when we say that entropy increases, we mean that the system is becoming more disordered. For instance, think about the ice in your drink. At first, it's solid and ordered, but as it melts, the water molecules spread out and move more freely, which means more disorder. That's an increase in entropy. It's exactly what the second law is talking about. The second law tells us that the total entropy of the universe, which includes the system and its surroundings, always increases in spontaneous processes. Now, let's bring this law to life with an example we all know: heat engines. Have you ever wondered why your car engine can't be 100% efficient? Or why your coffee cup cools down over time? That's because of the second law. You see, in a heat engine, some of the energy is always lost as waste heat. No matter how hard we try, we can never convert all of the heat energy into useful work. The Carnot engine, which is the theoretical perfect engine, can only have a maximum efficiency given by this equation is 1 minus Tc by Eth, where Tc is the cold reservoir's temperature and Eth is the hot reservoir's temperature. This equation tells us that the efficiency depends on the temperature difference between the two reservoirs. So, the second law sets the limit on the efficiency of any heat engine. Quick insight: the second law tells us that no heat engine can be 100% efficient, and some energy is always lost as waste heat. Let's dive into what makes processes spontaneous. In nature, things tend to happen on their own, like an ice cube melting or gas expanding to fill a room. According to the second law, these spontaneous processes result in an increase in entropy. Take the example of a gas expanding in a vacuum. The gas molecules, initially clustered together, will spread out and fill the entire container, increasing the disorder and thus the entropy. This is a perfect example of the second law at work. In a spontaneous process, entropy always increases. This is why it's harder to get an orderly system from a messy one without putting energy into it. Okay, now let's do some math and see the second law in action with a real-life example. Imagine a 1 kilogram block of ice at minus 10 degrees Celsius, and we are heating it up to 0 degrees Celsius. The specific heat capacity of ice is 2.1 joules per gram per degree Celsius. How much entropy changes during this heating process? First, we calculate the heat added using the formula Q equals m times C times delta T. Now, substitute the given values. Q equals 1000 grams times 2.1 joules per gram per degree Celsius times the difference between 0 degrees Celsius and minus 10 degrees Celsius, which is 10 degrees. This gives us Q equals 21,000 joules. Now, calculate the entropy change, delta S equals Q divided by T. So, the entropy changes delta S equals 21,000 divided by 273, which equals 77.0 joules per Kelvin. Thus, the entropy increases by 77.0 joules per Kelvin as the ice heats up, indicating a greater amount of disorder in the system. So, to wrap up, the second law of thermodynamics is all about understanding how energy flows and the inevitable increase in entropy, or disorder, that comes with it. Whether it's a heat engine, the melting of ice, or any spontaneous process, the second law tells us that systems naturally move toward more disorder over time. This law isn't just theoretical, it's something that affects everything around us, from refrigerators to car engines. So, the next time you feel the heat from your laptop or notice the ice in your drink melting, you'll know exactly what's happening, the second law in action. See you next time as we uncover even more fascinating principles of physics.